again, and hopefully this will work this time. Um, so. All right, my PowerPoint crashed. A lot of the writing that I had from my previous class and when I written on it earlier didn't save, but at least all my slides are still there. So let's try this one more time. All right, so again, we are finishing off our we got that time. All right, we are finishing off our idea of similar figures. This one starting off with similar triangles. I don't remember what I already said. So just know up here at the top, we're talking about our similar triangles, but now we're also adding in the idea of parallel lines. So on here, we have parallel lines. There we go. This is right. So we have parallel lines. Since we have parallel lines, that makes these sides proportional. So anytime you have a triangle and you have a parallel line drawn inside of that triangle, it's going to cut the sides so that they are proportional to one another. It's going to help us save time because down here on example 1, if we were to do this in the last section, we would have to compare the two triangles, the small triangle to the big triangle. When we were to do that, we would have to find like the length of this entire side, which was 24, and then the length of this entire side, which would have been 2x plus 24, and it would have taken a little bit extra time. Now, we don't have to find the length of this piece. We can just say, all right, since we have this parallel line with the one side, we can set these two up in fractions with each other and set them equal. So the 6 and the 8 can go in a fraction together, and then these two can go in a fraction together. And that's what they did down here. So we'll do a couple of examples with the information down bottom. But again, this is going to save us time. You can also do the opposite. If you wanted to prove that the line was parallel to the other side, you could show that the sides are proportional. So on this one, they gave us some information that we can label a triangle with. So they said that this piece HA is 5. They said that KG is 10. And they said that JL is 1/2 the length of the entire length of LG. So if I call that X, this would be 1/2 the length of LG. Sorry, not the whole length. This is there. So that'd be 2X. Now, they want to know, is this piece parallel? Well, if these are proportional, so these two to these two, then that line would have to be parallel. So I got 5 over 10 and X over 2X. On this one, that's the same 1X at the top, and this X can cancel off, so that's 1 over 2. If I cross multiply these, 5 times 2 is 10, 10 times 1 is also 10. They are equal, so that means that they are proportional to start off. And since they're proportional, we're able to say that yes, these two lines in fact are parallel. So we have two ideas there. The idea that if you have parallel lines in a triangle, then the sides are proportional, or if the sides are proportional when there's a line inside the triangle, then that line would have to be parallel. There's a third idea here about mid-segment. Now, we talked about mid-segment of a trapezoid right before we went on break. So let me draw that diagram real fast. If we had a trapezoid, then that piece was going to be parallel to both bases. And that middle piece was an average length of the two bases. So like if this was X and this was 3X, then this would have been 2X. All right. That middle piece is an average of the two bases. In a triangle, we don't have two bases. We only have one base. So on here, if I draw in a mid-segment, I'm going to have a triangle. I'm going to have two midpoints. And when I say midpoint, that means that we have these two pieces would have to be congruent. These two pieces would have to be congruent. So we have two midpoints for two of our sides. We have a line connecting them. That'd be a mid-segment. And when we have that mid-segment, again, it's going to be parallel to that third side. It's also going to be half of the third side. So this is X. This side is going to be 2X. So a similar idea, but on our trapezoid where we took the average of the two bases, here we only have one base. We're going to take half of that base, and that's going to give us the length of the mid-segment. Now, let's look at some other examples. So on number one, we have 5, 5, 7, and X. All right. Well, this one is dealing with mid-segments. We have these two pieces are congruent. So this is definitely a midpoint. And we're going from a midpoint and have this parallel line coming from it. That means that this must also be intersecting the other midpoint. So this is a mid segment. And these two must be congruent. So what's X? 7. We don't even have to do any work on that one. Now, nah, not all of them are like that. So on 2, now, is this a mid segment? No, these two aren't congruent. But again, we can set a proportion to solve. So set a proportion, these two in a ratio with each other, these two in a ratio with each other, and set them equal. 1 over X is equal to 18 over 9. Cross multiply and solve. Again, same thing that we've done on pretty much every problem in this entire chapter. Divide off the 18 and 10 is X. All right, again, most of those problems are like that. On the other side, they added in one other idea, and that extends this idea of parallel lines not only to just triangles, but to any time that we have parallel lines intersecting more than one transversal. So here we have 2 transversals cut by 3 parallel lines. Well, the corresponding parts within these lines are going to be proportional. So A over B is going to be equal to C over D. On the other one, our parallel lines are going the other way, cutting these 2 transversals. So UV is going to be proportional to W and S. Yeah, set them up in a ratio, set them equal. And if you needed to solve for one of those pieces, you could solve for one of those pieces. Down here, they give an example where they're actually plugging in values for each of those. We're going to do one of the other examples down at the bottom so that we can start from scratch. But same idea. On number 1, again, we have lines cut by 3 parallel lines. So we got these 2 transversals. We have 3 parallel lines. Now, these 2 are going to be set up in a ratio. These 2 can be set up in a ratio. Again, we're going to set them equal. So let's rotate this. I'm going to have X 5X over 3X. Again, it's all about setting up the correct proportion and then solving. Well, I have X here and X here. I can divide X off of both of those. So now I just have 5 over 3. And now we can cross multiply and solve. So 3 times 12. Again, this one takes a couple steps because we have to distribute first. And then once we distribute, we'll be able to continue solving. So 3x times 36. 5 times 12 is going to give us what? 5 times 12 is 60. Now we can solve for x. Get our 36 over to the other side. It was adding, so we got to subtract it. 4. Divide off the 3, and x is what? Now, there are a couple problems on here where we don't have to set a proportion. So I'm going to do an example of one of those. So if you look at number 3, this one we can get away with not doing a proportion because they tell us that we have some congruent parts. They tell us that these 2 pieces are congruent. Well, if those 2 pieces are congruent, what does that mean about those 2? They're also congruent. Now, again, is it going to be the exact same measure as these? No, but they're congruent to each other. So we can set up 2 separate equations to solve. We have the x's are congruent. The y values over here are congruent. So 2x plus 4 is equal to 3x minus 1. And on the other side, 2. We can bring like terms over to the same side. So the 2x we can bring over here. Subtract out 2x, that leaves us with just 1x. Bring the 1 over to the other side. That's going to bring us 5. Right? So x is equal to 5. On the other one, bring 2y over to the side by subtracting it. Leaves us with 1y, which is y. So y is equal to 2. Again, some of these we can get away without saying up proportions. If you have a congruent symbol in there, then again, that makes it a little bit easier. 2 on that one. Let's go to the next one. Oh, sorry, did anybody still do that one for you? I'll leave it up there for a minute so you can get a copy. Okay, all this section is all about just making sure you have the correct setup at the beginning for a proportion. Once you have the correct setup, it's the same stuff every time. Cross, multiply, and solve. There's only a few in there that are slightly different. But again, if you have a congruent symbol in there, then you have parts that are congruent. And that saves you time because you can set things equal and solve. It's very repetitive, this chapter. That's why since we've come this far, I thought we could do these last two sections. Knocking out today. All right. 7.5. So again, still dealing with the same ideas. We already talked about anytime we have similar figures, all the corresponding parts are going to be sharing that same scale factor, that same proportional ratio, right? Well, same thing here. When we have triangles, all the corresponding parts in a triangle, whether it is the altitudes, the angle bisectors, the medians, all those pieces are going to have proportional lengths, right? Again, I'll say it just like I did when we talked about our perimeter. Any single dimensional measurement that corresponds in two similar figures is going to be proportional. So on here, we have sides, and then we have this line drawn in. Well, this line is an angle bisector. If these two triangles are proportional, then the ratio between the sides is also the same as the ratio between the angle bisector length. So they set up a ratio and solve for the missing piece. Again, it's the same thing we've been doing, just with multiple parts. On number 1 up here, for example, we have, well, now that's not an angle bisector. That's going from an angle to the midpoint of the other side. That's a median. On here, we also have the same median drawn in. So those two pieces have to be proportional with those sides. Yeah, we can just set up a ratio. So comparing similar sides, 36 and 18, 20 and x. Yeah, there's more than one way that you could set up that ratio, but once you do, you can cross multiply and solve. If you want to, you can also simplify this first, because 36 and 18, those reduce nicely, right? That reduces all the way down to just 2 and 1. So now we cross multiply, it's even easier. 2 times x is 2x. 1 times 20, 20. Divide off the 2 and x is 10. Now we got our answer. Now, even if the measurement pertaining to the two figures is on the outside, like on number 4, we have an altitude drawn in, and the height is given to us in terms of x and 7. Well, again, the ratio of those has to be proportional to the ratio of all the sides. So if I know that the sides here, I have 10 over 8. Let's go ahead and just change this to a scale factor real quick. 10 over 8 reduces down to 5 over 4. All right, so I can use that scale factor for those sides as well. And you're always welcome to reduce first, find a scale factor, and then use that in the proportion. Or if you want to set the proportion right away, that's fine too. Both ways work. But 5 over 4 will be equal to x over 7. Cross multiply and solve. 4 times x. 5 times 7 is 35. Get x back evenly, but it's not a horrible decimal. And it's what, 8.75? That's it. Questions so far? All right. I'd say out of all the things on these two worksheets, the last one is probably the most different, but it's not even that bad. All right. This is something that is special just for angle bisector. All right. Just for angle bisector. So everything else, again, everything else works for any piece. But now this one is very specific to an angle bisector. If you draw in an angle bisector, notice it's not the angle bisector that they have labeled here. In fact, they don't actually have two separate triangles here. But there is something that an angle bisector does in one triangle by itself that allows us to set up parts that are proportional to one another. So this is just in a single triangle, not two triangles. So parts, again, these parts are just in one triangle, not two different ones. We have an angle bisector drawn in. And the two sides of that angle that was being bisected will be proportional to the two parts on that third side that were split by the angle bisected. So on here, what you can do, you can take these two and set up in a fraction, and these two and set up in a fraction, and they should be equal. The two sides compared to the two sides that were split there, on that third side, those will be proportional. All right, and that's what they did when they set this up. All right. So we're gonna do, let's do two examples using the ones that are over here. Let's just do number 6 first. So on here, I have, this is the angle that's being bisected. So the two sides from that angle, I'm gonna set up in a ratio. And then the two parts that were split for that third side will be my other ratio. I'm just gonna set them equal. So I have 11 over x equals 17 over x plus 7. Again, this only works for an angle bisect. So this one's special, and this one's only dealing with one triangle instead of two. Right? Everything else that we've done in this chapter is 2. But it's still all about saying up the correct proportion and solve. Once you have that, cross multiply and get an answer. So I have 17 times x and 11 times x plus 7. On this side, I will have to distribute. Bring like terms over the same side, so the 11x I can subtract anything with 6x equals 77. Again, doesn't go in evenly. We're gonna have to divide that one off, and it's like 12 point something continuous. Anybody got calculator? I don't know that one off the top of my head. It's like 12 point, oh, it's 5.6. I think it's like 8.6, 8.3. I can't remember. Somebody do it. Divide. 77 divided by 6. What's it give? 8.3. All right. I know it was one of those. I can't remember which one. So that's it. That's the final answer. You want to do one more from this side? They're all very similar. Let's do number 4, because number 4, they don't have the parts labeled that we need. So on here, we have x, we have, actually, let's do this. This one looks a little bit harder. Let's do number 3. All right, on 3. So we need to set up the ratios. We have the two sides from the angle, right? So I'm going to split those. One goes on top, one goes on bottom, right? But then, what am I saying it equal to? So, like I said, to equal to these two pieces over here. Well, what are those two pieces? So the n is on the same side as the 42, but what goes on top? That's the one that might be slightly tricky. Well, I know the full length, right? How would I normally find these if these were just two numbers? I'd have to what? Divide, not divide. If this was, so I have a number here. Let's say that this was just 5 for a second. What would I do to find that piece? Subtract it. Same thing. We're subtracting it. We don't know what that number is, but just like all these other problems, it's okay to have an expression, right? We just had an expression in this last problem. We didn't think anything of it. Same thing here. We're just subtracting off n from the total so that we have something to represent that missing piece. Cross multiply and solve. The thing that we've been doing. Now, these are really big numbers. I would highly recommend reducing these. Both of these are divided by at least 6. Let's see, is there anything big that goes into those? I think 6 is probably going to be the best. If we divide those by 6, this would be 6 and 7. So cross multiply and solve. 6 times n, 7 times 4.28 minus n. Again, that's 7 be multiplied to both parts of that. Not very clean. This one would be easy to do with a calculator. Not to do in my head. Have it for me instead of me trying to go through in my head. 3276. Get your like terms the same side. So I had negative 7n over here. Bring it over by adding it. So we have now 13. Much better if you have a calculator. Now I got to divide by 13. Glad we did this one together. All right. Divide that, what do you get? 2.52? And it wasn't any other decimals, it just rounded nice like that. Oh, 5.2. Sorry, 5.2. Like that. Again, it's almost the same thing every time, right? This little piece is the part that's the most different out of anyone, because you're just dealing with one triangle being split by a angle bisector. Everything else is two triangles, making sure you're setting up corresponding pieces and then solving. Here, we're still making sure we're setting up the correct pieces in a proportion, cross multiplying and solving. So, any questions? All right. If my count in my head was correctly, I think you have 17 problems left. Is that right? Or did we do 2 from each page? I feel like there's one that I only did 1. 2. Actually, no, I think there's 16 problems left since I did 2 from each. So you have 16 problems left. Go through, do the rest. That's your assignment. You have a 3-day weekend. Get it done. The assignment's already posted. Wait, did I actually hit post? Does anybody know the assignment actually showing yet? Yeah, it's like actually got post this morning. Okay, I got to publish it then. But I'll go publish it right now. Oh, what time we got here? 30. Okay. So I did want to go over answers from yesterday's homework. However, if I flip back, all the answers I wrote in this morning are now gone. So when my PowerPoint failed me, all my work from this morning disappeared. So what I'll do, I'll go back through and write it all back in and post the answers so you can check your work. And that way, when we go over this assignment, if you have any questions on the previous assignment, we can go over those as well. But yeah, all my answers are done already. So normally PowerPoint auto saves it for me, but it failed this time. All right, I'll go back to that last slide because I wasn't sure if everybody was done copying that last piece. Freeze it there. And you have your assignment.